Now, before I forget, there's one more thing I want to do in the emitter. If we jump into the flip source, and I'm just going to press spacebar and F to focus in on our selected node. I'm just going to put this in wireframe so we can see the points. So if I press play now, you can kind of see they're kind of static. So to get just a bit more variation in their initial position, you can use this jitter seed, right? So if I move that, you can see they move. And to get this moving per frame, we've done this before, $F, and that way when I press play, each frame they'll have a different position. Okay, the jitter scale is just how much they move. If I put this to 0, you can see it'll be in a grid. So 1 is fine for us. Can't see any pattern there. So just that. What I want to focus on now, so if the last flipbook we did was pretty chaotic, you know, there wasn't much form in the splash of the fluid. So I'm going to look at adding a couple of things just to demonstrate. I'm just going to make another dot network here, actually, just to have something simple and clear. You don't have to do this if you don't want to, just for demonstration. It's up to you. So I'm just going to drop in another .NET and another flip solver, right, with some gravity in there, and then a flip object. So I'm just going to use the default, default cube for this. And let's bring down the size of this. If we go into volume motion, I think it's in volume motion. Where is it? Yeah, the box size. If I just middle click, go down to 20, or maybe move it up 10. Something like that. So let's get rid of the ground plane. Well, move it down up 5 maybe, just so it's not on the ground. There we go. And then I'm going to bring the particle separation down. Let's do 0.2, let's say. And the guide particles, turn this to particles, just so we've got dots there. Okay. And let's see, maybe jitter it a bit as well. Let's see. There we go. Put it up to 1. Great. So what I want to look at, let's just press play and see what we get from this cube. See that drop? Splash on the and disappear through the ground. One thing I forgot to do is turn on these closed boundaries, so that makes this like one big collider in a sense. I'm gonna make this a little bit smaller as well. Let's go down to there. Okay, press play again and see. It'll be pretty. So we even get a square where it lands on the ground. See, it doesn't look very realistic there. So what I want to do is look at viscosity. So we've already done that when we did the ice cream, but we're also going to look at surface tension in this lesson. So let's just turn that on first of all and see if we get anything different from. So instantly we can see we don't get a square as it splashes on the ground, get a circle, and that's because even before it's collided with anything, it's trying to form a circle, basically a sphere. It's, you know, the surface is pulling itself around and trying to form more fluid shapes, right? So the surface tension can be really helpful for forming these kind of tendrils. You've got to be careful with it. If we put it up too high, you get some weird kind of oily looking, which may be what you want, but it can be easy to go over the top with it. There you can really see it being pushed there, and you get these snaky, oily kind of forms with it, right? And again, it does depend on the scale, and you know, you can play around here just to get a sense of it. But even when we move on to our other sim, we'll, you know, we will have to play around a little bit with it. And let's try adding some viscosity as well. I'll just turn that on. Remember, in the other lesson, we used the viscosity attribute, which we imported, but we don't have that here because we've only got the one fluid, so it's not necessary. But remember, you need to actually give it some viscosity here. I put it up to something pretty low. As this is so small, I'm using pretty low values here. When we go to the other sim, we'll raise them up a bit. So there you see they're kind of competing with each other now. You can see the viscosity holding it together. Just put this way down to 3 or something. So you can see the surface tension pulling it round, viscosity holding it together. You're starting to get a bit more details there. Maybe even less. That down to 1. Okay, starting to get something a bit more interesting there. Another thing I wanted to look at is the velocity transfer. So the way that flip works, it's kind of almost like an interplay between volumes and particles. What we're watching, what we're visualizing is the particles, but the way the velocity is calculated, it takes the volume motion into account. So that's why we have things like volume motion here, and the velocity is kind of an interplay between the two. So we got two options here. We got splashy kernel and swirly kernel, which is kind of self-explanatory. But what we can also do, just to get some more information on any parameter really, if you just hold the mouse over, you'll get a little bit of a description. So this says, specifies the method for using transfer velocity from particles to the underlying grid before solving them back to the particles. Doesn't help us too much. It sounds a bit complex, convoluted. But then underneath, even more useful, in my opinion, if you see it says press F1, so let's do that. And that will take us directly to the side effects help pages. And we can see we're in the help pages for the flip solver. So I highly recommend doing that when you're playing around with, we've got so many different parameters. Lots of these we haven't touched, but it's useful to go around and, basically changing things, seeing what happens, putting up the values a lot and experimenting, but also coming in here to read the explanations. So right at the beginning, we've got a splashy versus swirly kernel. So we can take a look at that. And basically it says here, see, we've got splashy. Swirly kernel is typically used for high vorticity simulations where you need to reduce surface noise as much as possible, okay, while still retaining the swirly nature of the simulation. For example, small scale fluids. So in our case, it is kind of more of a small scale thing. We got a splash against a strawberry. We don't have a big river or a beach scene or something, which is quite common to do. So let's try this swirly kernel instead. I'll flip that over and see. I'm not sure if we get much difference here with this small cube, but we'll definitely switch that over on our other sim. Okay, so let's I'm just going to jump out of this, delete it. This strawberry I'm just going to visualize, just because it doesn't look nice with the mountains. So I'm just going to visualize it from here. Put this back to smooth wire shaded, and let's implement those in here. So I want to turn on the swirly kernel. Okay, enable viscosity and surface tension. The numbers here are going to be higher because we do have, the volume is bigger. We've got a bigger sim going on here, so we need more surface tension. We've got more velocity. We've got the it's been kind of squirted out the side of this, of the emitter, right? So I'm going to push that up to 300. And the viscosity as well, I'm going to push that up to about the same, 350. All right, I'm going to leave this, let's push it down. Well, I'll leave it at 3. I'm going to push these sub steps up. So if you remember, each frame, the flip solver will calculate the position of each particle. So if you want to get more detail, we need to calculate it more times per frame. So that's what substeps are. So if we jump here into the dot network, we can add more substeps here. I'm going to put this up to, let's just do 2 for now, just double it. Let's jump inside there. So we got our, just to double check, we got our viscosity, particle separation at 3. Let's drop that down to 2. A bit more, kind of creeping up in the numbers. Yeah, we got our surface tension, viscosity, and swirly kernel turned on. Okay, so back to our camera, full screen, and let's have a look at this flipbook. So flipbook is done. Let's take a look at what we've got. It's certainly different. Again, I'll jump this up to frame 38 there. Just watch that part, the slow motion bit. So you can see it's definitely holding together a bit better now. Getting this kind of envelope around with some blobs around. There's some kind of drips being pushed away, some tendrils here. So it's cool. It's still a bit big though, but I'm going to be pushing up the sub steps and the particle separation in a minute, and that will calm things down a bit. So it's kind of a balancing act, you know. It's a bit difficult, but you know, the more if we drop down the particle separation, it will slow down a little bit. Okay.